Electrophilic addition reactions of isolated dienes. Isolated dienes react exactly like alkenes. In order for us to understand this, we need to remind ourselves of a very important rule. So if we have a secondary carbocation versus a tertiary carbocation, this would be more stable. And for that, you would like to add the halogen in an electrophilic addition reaction to the more stable carbocation. So this is a secondary and this is a tertiary. And I mentioned this because we're going to see it here. So really quick, you have this reaction right here. You have two double bonds, and therefore the reaction, if we have only one equivalence, 1 mole, that's it. You have two possibilities. You can add it to this double bond, the H and the Cl, or the double bond on the left. Well, we just mentioned that if you have a carbocation, tertiary is more stable. Therefore, this carbon right there is more reactive because the carbocation is more stable because it yields a tertiary carbocation. Whereas this one would yield a secondary carbocation. Actually, this one right there. So if we were just to show you the first step, if you recall this from organic 1 really quick, the double bond would attack, bond would break between the hydrogen and the chloride. And then you would get following. Okay, so there's a plus sign right there. So where was your H added? If you recall from organic 1, this is your H. Let's say it's right there. So there you go. You have a tertiary carbocation. So then you would have Cl minus attacking that carbocation. And of course, you would get your product, the halogenated product. Now, what if you have excess, meaning more than one? So you can have two equivalents or more. Then you would substitute both double bonds. So you would add your Cl there, and it would be the following. Very well. Remember, our Kovalnikov's rule adds the H where there are less H's, and of course the halogen where you have, apologize, let's go back. You add the Cl where you have less H's, and you add the H where you have more H's. So this one has more H's. That's why you added an H to it, as you see right there. Very well. That is not our discussion. We brought this up just to show you how different this would be from an electrophilic addition reaction of conjugated dienes. So for conjugated dienes, there's a difference here, is that if you have one equivalence, you actually end up with two products. As you saw here, you ended up with one product for one equivalence right here. With electrophilic additions to conjugated dienes, you get a 1, 2, and 1, 4 additions. Very well. So let's actually show you the products. So the products that you would get here would be the following. And I'm going to draw the H's. And then, of course, you would get the other product. So I'm showing these H's for a reason. So this is called the 1, 2 product, and this is called the 1, 4 product. Very well. What happens in the mechanism here? Well, we have to talk about that. So if I have HCl here, and I have the conjugated diene, first step is the attack of double bond at hydrogen, and then that would result in following. So we added the H. Here are we added the H to the one that has more H's. And then there's a positive charge on this carbon right there. Once again, I'm going to draw the H's at the end here because they're important. Very well. Now, if you notice here, you have a resonance structure. So you can have a resonance structure where, if you recall, this is an allylic where we move the double bond. So now it's in between. And now there's a positive charge. On the last carbon on the left. Well, if you notice here, if we have the Cl minus the chloride ion, the chloride ion has two ways to attack the intermediate, the carbocation. So the first one would be to attack that carbon right there, the carbocation, or to attack the carbon at the end. Let me just put it this way like that. And of course, if it goes this way, then you would get this product, and I'm going to circle the Cl and the H. And if it goes through the second pathway, then it would give you the second product, the 1,4. Why is it called a 1,2 and a 1,4? For a very simple reason. If we say a 1,2, if we start numbering it, this would be 1, 2, 3, and 4. So when we say 1,2, means we added the carbon, so we added the hydrogen and the chloride to the first and the second carbons. However, so for this would be your 1 and that would be your 2. For the second product, it would be a 1 and 4, because if you look, let's just number these. This is 1, this is 2, this is 3, and that's 4. So here we have stabilization by resonance. As you can see in the diagrams.